This video is about discriminant of a quadratic function. We know for y equals ax squared plus bx plus c, the discriminant will be b squared minus 4ac. We use the discriminant of a quadratic function to decide how many roots the quadratic function has. When b squared minus 4ac greater than 0, for a greater than 0, there will be two roots, which means the graph will open up. We have two x-intercepts. When a less than 0, the graph opens down like this. We have two roots. So two roots. When b squared minus 4ac equals 0, when a greater than 0, the graph opens up. The graph will touch x-axis only once. When a less than 0, graph opens down. The graph will touch the x-axis once, one root. When b squared minus 4ac less than 0, for a greater than 0, the graph opens up. Will be like this, no x-intercept. When a less than 0, the graph like this. A won't touch x-axis. So we say this is a no root, no real root. It will have a complex root. Let's look at some examples about discriminant problems. Number 1, the quadratic equation x squared plus 3p plus 4x plus 1 equals 0. In what value for p, the equation has no solution? We know for y equals ax squared plus bx plus c, when b squared minus 4ac less than 0, there's no real solutions. So for this equation, we have a equals 1, b equals 3p plus 4, c equals 1. Then b squared minus 4ac equals 3p plus 4 squared minus 4 times 1 times 1. We go to use a plus b squared. That is a squared plus 2ab plus b squared. So you have 9p squared plus 2ab will be 24p plus 16, then minus 4. Combine like terms, 9p squared plus 24p plus 12. We will set up this less than 0. We go to solve this inequalities, quadratic inequality. First step, divided by 3 both sides. 3p squared plus 8p plus 4 less than 0. For solving quadratic inequalities, first step, figure out the roots. 3p squared plus 8p plus 4 equals 0. Major x, 12, 8 over 3 over 3, 2, 6. Reduce. Variables is p. Bottom up. 3p plus 2 times p plus 2 equals 0. So p1 equals negative 2 over 3. P2 equals -2. Second step, sketch the graph. Because A equals 3, opens up. So the graph like this. And this is -2. This is -2/3. Less than 0. It will be this part. The graph below x-axis. So we can write down the solution. That is this P greater than -2, less than -2/3. Then the equation has no solution. Now let's go to number 2. Consider f of x equals 2kx squared minus 4kx plus 1. K is not equal to 0. The equation f of x equals 0 has 2 equal roots. Find the value of k. 2 equal roots, which means discriminant b squared minus 4ac equals 0. We know a equals 2k, b equals -4k, c equals 1. We will set up b squared minus 4ac equals 0. b squared will be -4k squared minus 4 times 2k times 1. -4k squared will be 16k squared minus 8k. We will set up this equals 0. First of all, let's factor. Common factor will be 8k. 2k minus 1 equals 0. k1 equals 0. k2 equals 1/2 because 2k minus 1 equals 0. That is 1/2. Since we already given k is not equal to 0, so we cross this out. K equals 1/2 will be the solution. Now let's go to B. The line y equals p intersects the graph of f. Find all possible values of p. Let's check our quadratic function. F of x equals k equals 1/2. So 2 times 1/2 x squared minus 4 times 1/2 x plus 1. X squared minus 2x plus 1. X squared minus 2x plus 1, the graph opens up. Y equals p will be a horizontal line. It could be like this. It could be like this. It could be like this. This said the line y equals p intersects the graph of f. When this p is greater than or equal to this vertex. For this vertex, hk. Remember, for this k is not this k. They are different. When this p greater than or equal to this k, then y equals p will intersect the graph of f of x. We know that a equals 1, b equals -2, c equals 1, and h equals -b/2a. That is 2/2 times 1 equals 1. For k equals f of 1. 1 squared minus 2 times 1 plus 1 equals 0. In other words, when p greater than or equal to 0, then p equals y will intersect the graph of f. Look at number 3. The equation has roots. This is a quadratic function. When you say has roots, which means discriminant b squared minus 4ac greater than or equal to 0. From this equation, we know a equals 1 over 2, b equals k minus 2, c equals k squared plus 4. For b squared minus 4ac equals k minus 2 squared minus 4 times 1 over 2 times k squared plus 4. K minus 2 squared will be k squared minus 4k plus 4, because a plus b squared equals a squared plus 2ab plus b squared. Then negative 4 times 1/2 will be negative 2, k squared plus 4. That equals k squared minus 4k plus 4 minus 2k squared minus 8. Combine like terms, negative k squared minus 4k minus 4. We set up this greater than or equal to 0. We will solve these inequalities. So first step, solve for the roots. Negative k squared minus 4k minus 4 equals 0. Then divide by negative 1 both sides. You will get k squared plus 4k plus 4 equals 0. Factor, you will get k plus 2 squared equals 0. We only have one solution, k equals negative 2. Then the second step, try to sketch the graph. We know a equals negative 1 from here. The graph opens down. Since we only have one solution here, k equals negative 2, the graph will only touch x-axis once. The graph will be like this. Since we are solving negative k squared minus 4k minus 4 greater than or equal to 0, which means we are looking for the graph above or on the x-axis. From the graph we sketched, we could say only one k equals negative 2. The graph is on the x-axis. For other value of k, the graph is always below x-axis. In other words, k equals negative 2 will be the only solution, so that this equation has roots. Let's go to number 4. Explain why the equation 3x squared plus kx minus 1 equals 0. K is all real numbers, always have 2 roots. If you want to prove a quadratic function always have 2 roots, you just need to prove the discriminant b squared minus 4ac greater than 0, always true. For this equation, we get a equals 3, b equals k, c equals negative 1. Then discriminant b squared minus 4ac equals k squared minus 4 times 3 times negative 1, k squared plus 12. Since k squared plus 12 greater than 0 is always true, the equation 3x squared plus kx minus 1 equals 0 always have 2 roots.